Dear students, in this video I am going to explain theory of fluorimetry, factors affecting fluorescence and fluorescence quenching. Now let's start. Luminescence is the emission of light by substance which is not heated. It is also known as cold light. There is one more phenomena known as incandescence, in which the substance is heated and after heating the substance starts emitting radiation. But in luminescence, substance is not heated. Instead of that, substance absorbs radiation and it re-emits same radiation or different radiations. It occurs when electron return to the electronic ground state from an excited state and loses its excess energy as photon. Luminescence, it means a substance is shining. Many types of luminescence are observed in nature like bioluminescence, chemiluminescence or photoluminescence. We'll study photoluminescence. There are two types of photoluminescence, fluorescence and phosphorescence. Now we'll go for theory. Before starting the theory of fluorescence and phosphorescence, one should keep in mind some points. The first point is a molecular electronic state in which all the electrons are paired are called as singlet state. That means in singlet state, the electronic spin is paired or anti-parallel. In singlet state, the molecules are diamagnetic in nature because due to paired spin or anti-parallel spin, the electrons do not show any magnetic movement. Second point is a molecular electronic state in which all electrons are unpaired or parallel. It is called as triplet state. Here in triplet state, the spin of electron is parallel or anti-paired. In triplet state, the molecules are paramagnetic in nature. Due to unpaired or same spin, the magnetic moments of both electrons get combined and they behave like tiny magnet, and that's why the molecules behave like paramagnetic substance. Most of the molecules in their ground state are in singlet state, that means the spin is paired. When such molecule absorb UV or visible radiation, one or more of paired electron raise to the excited singlet state. Now we'll see diagrammatically the concepts of fluorimetry. Consider this is the energy of UV visible radiations. Generally, the electrons of organic molecule are in ground state, singlet ground state, where the spin of electron is paired. When the electrons absorb UV visible radiation, they jump to the excited state, which is known as singlet excited state, where the spin of electron is again paired. Here vibrational relaxation of electrons occur. A singlet excited state is the excited state. It is unstable. So electrons will not spend more time in this state. Electrons will try to lose their energy and come to the ground state. In some molecules, the electrons show internal conversion and they travel to a less energy state, and from this less energy state electrons lose their complete energy in the form of radiation, which is known as fluorescence. Now there are certain compounds which show intersystem crossover, and the electrons come to the triplet excited state, which is a less energy state than the singlet excited state. Here the spin of electron is parallel or unpaired. The triplet, as we know that triplet excited state is a less energy state, so electron will spend more time in this state but still it is an excited one, so it is unstable. And now the electrons will come to the ground state by losing energy in the form of radiation, which is known as phosphorescence. So this is the complete theory or concept of fluorescence and phosphorescence. Now we'll go towards fluorescence in detail. When a beam of light, generally UV or visible radiations, is incident on certain substance, they re-emit visible light. This is known as fluorescence. The radiations are emitted by the radiation source. Those radiations, UV or visible radiations, pass through the sample, and after absorbing UV and visible radiations, samples start shining and it start re-emitting the radiations. It is known as fluorescence. Fluorescence starts immediately after the absorption of light and it stops as soon as the incident light is cut off. Fluorescence is an instant process. It takes 10 raised to minus 4 to 10 raised to minus 8 seconds. Re-emitted radiations are longer wavelength radiations than the absorbed radiations. Now we'll see phosphorescence. When light radiation is incident on certain substance, they emit the light continuously even after the incident light is cut off. That means phosphorescence will go on even if we stop the radiation source, then also the light is re-emitted. That is known as phosphorescence. This type of delayed fluorescence is known as phosphorescence. Phosphorescence is a delayed process. It takes 10 raised to minus 4 to few seconds. That means longer time than the fluorescence. Now, which compounds will show fluorescence? Generally, the fluorescence is most commonly observed in the compounds containing aromatic functional groups with low energy. Most of the non-substituted aromatic hydrocarbons show fluorescence, and fluorescence will increase with number of rings and degree of condensation. Now, simple heterocyclic rings do not exhibit fluorescence, like pyridine, furan, pyrrole. They do not show fluorescence. But when the fusion of these heterocyclic nucleus with benzene ring occur, they show fluorescence. Like pyridine condensed with benzene ring, it becomes quinoline or isoquinoline. Then they show fluorescence. Same way indole also show fluorescence. Condensation of benzene ring with pyrrole. Now we'll go for factors affecting fluorescence. The first factor is nature of molecule. Next is nature of substituent, effect of concentration, light, oxygen, pH, temperature, viscosity, intensity of incident light. Now we'll see in detail one by one. Nature of molecule. The molecule which absorb UV or visible radiation can show this phenomena. Greater the absorbency of molecule, more will be the fluorescence. Now, nature of substituent. Electron donating group enhance fluorescence, for example amino group, phenolic or alcoholic group, etc. Electron withdrawing groups decreases or destroy fluorescence, like carboxylic acid group, nitro group, azo group, etc. Now, effect of concentration. Fluorescence is directly proportional to concentration. That means here Beer's law is obeyed. As the concentration increases, fluorescence will increase. Next factor, light. Monochromatic light is essential for excitation of fluorescence because the intensity will vary with wavelength. That means monochromatic light will increase fluorescence. If polychromatic light is used, it will reduce fluorescence. Oxygen. Oxygen may directly oxidize the substance, fluorescent substance, and convert it into non-fluorescent, or oxygen may show quenching of fluorescence. That means presence of oxygen will decrease fluorescence. pH. Alteration of pH of solution will give significant effect on fluorescence. For example, quinoline show fluorescence in acidic medium. If we increase the pH, the fluorescence will destroyed. Temperature. Increase in the temperature will decrease fluorescence. Now viscosity. Decrease in the viscosity will decrease fluorescence. Last is intensity of incident light. Increase in the intensity of incident light on sample result in increase in fluorescence intensity. Now fluorescence quenching. Decrease in the fluorescence intensity is known as fluorescence quenching. That means decreased fluorescence. It occurs due to change in concentration, pH, temperature or viscosity, etc. Types of quenching: self-quenching, chemical quenching, static quenching and collision quenching. Now self-quenching. At low concentration range, Beer's law is obeyed. Fluorescence is directly proportional to concentration, but it is obeyed in low concentration. But at higher concentration range, Beer's law is not obeyed. If we put concentration and fluorescence on x and y axis respectively, and we plot the graph, at low concentration we'll get straight line. That means as the concentration increases, fluorescence will increase. But at higher concentration, when we put the same type of graph, we will not get straight line. Instead of that, we'll get curved line, because at higher concentration the relation between concentration and fluorescence will not be linear. It is known as self-quenching. Chemical quenching. Fluorescence intensity decreases due to factors like change in pH, presence of oxygen, halides or heavy metals. Aniline at pH 5 to 13 gives fluorescence, but below 5 and above 13 it does not exhibit fluorescence. Halides like chloride, bromide, iodide and electron withdrawing groups like nitro carboxylic acid group leads to quenching of fluorescence. Heavy metals lead to quenching because of collision of triplet ground state. There are another two types of quenching like static quenching, in which due to complex formation, quenching of fluorescence occur. For example, caffeine shows quenching of fluorescence of riboflavin. And one more quenching due to collision, increased collisions, quenching occurs. Now I hope you understood all these things. Thank you for watching my video.